So in between, we will try to give some activity without seeing the screen. Okay, just like a kind of activity where you are going to draw or you are going to create with your innovative thoughts that what kind of drones or unmanned aerial vehicle you want to make it for, any kind of applications what you are feeling where drone is necessary. Okay, those things also we will give for 15 to 30 minutes in between. No need to submit, just it's for generating your ideas in your own way without seeing the screen. Okay, fine. Okay, hope we can start the session. I think so. Any specific queries? Okay, thank you. Then we will start the first session today. We are going to talk about all the unmanned aerial vehicle related things. Okay, the screen is visible?
Sir?
Yeah, please.
Sir, if possible, can you give me permission to record on my computer if possible, sir?
I think we have to discuss with the team here. Okay. Once they are saying here that you can record, then you can please go ahead. Okay. I will ask maybe after 12, I will ask them. Okay. Otherwise, in between, we are going to have a 10 minutes break, right? At that time, I'll ask them. Once they are saying that yes, then I will tell you what to do. Okay.
Okay, thank you.
Yeah, okay.
So you will be uploading the slides, sir?
I will give a PDF. Yeah, sure.
Okay.
All the PDFs I will give. Okay, based on this PDF only, your quiz will come. Got it?
Yes, sir.
Okay, sir.
Yeah, fine then. Okay, so just we are going to talk about today the unmanned vehicles. Actually, generally, here I have given as like title Introduction to Aerial Robotics. Actually, we are going to talk about what kind of vehicles we are coming across. Okay, robotics. I think everyone knows. I think so. So. If you want to be a robotics engineer, you know that you should be well versed in mechanical engineering, and you should be having some knowledge in electrical and electronics engineering, and you should have some knowledge in computer science and engineering. Okay. Apart from that, we should have some mathematical knowledge also. Then only we can call ourselves as robotics engineer. Okay. Some of them, maybe your friends or you may be too good in simulation. Some of them will be too good in design, and some of them too good in controlling the robots, and then some of them they will be too good in programming. Okay, so all these knowledge together only will give you a name called robotics engineer, or it's like a multidisciplinary engineer. Okay, that's the thing I want to convey to you, because when you need something to make and then execute, you should have all this knowledge. And coming to the content today, so instead of talking only about history and unmanned aerial vehicles, so I have come across that what are the vehicles are there related to where a human is not needed. One is unmanned vehicles, second one is unmanned aerial vehicles. So we are going to talk about these two as a brief intro to unmanned vehicles and unmanned aerial vehicles. After that, we are going to see about the components of a drone, or we can say that aerial vehicle, and then the basic mechanics in aerial vehicles, then how to select the component of that, and then system architecture, and then introduction to sensor. We are not going to see in detail about the sensors, but we are going to see the simple, what are the minimum sensors are required for the drone. Okay. After that, we are going to see the recent trends in UAV. Anyway, our expert will talk to you in detail in the role of UAV in the afternoon session, but I want to give a few glimpses of that. Okay, that's the thing. And unmanned vehicles, generally, if we hear this term, we will say that, okay, in the vehicle, the man should not be there. Okay, that is a thing. But anyway, we will monitor nowadays, okay, what is happened to the unmanned vehicle. The simple example, maybe as you are a student and you are learning all these terms means, Tesla will be a good example for that, okay. And nowadays, they are developing a huge number of cars, autonomous cars or self-driving cars, okay, as an unmanned vehicle in the ground. And they are achieving also. Okay, that's the thing. And generally, if you come to unmanned vehicles, means it's known as a powered vehicles. Okay, it can be in anywhere, air, maritime, and then ground. And one more thing is, They do not carry a human operator. We know very well about that. And it can be operated autonomously or remotely. Okay, this one. So here only we need researchers. Okay, even though Tesla is manufacturing cars and autonomous cars, but we have seen a lot of videos that it could not predict the obstacle which are in the national highway. Okay, so even we need so many programmers or so many engineers to overcome all those issues. Still, there are some what is that the contradiction is going on whether it should be autonomous or remotely should be operated. But people like that they want to be autonomous cars, and then they want to simply sit and then they want to reach their destination. Okay, to date, I think 40% they have achieved within known environment. Okay, unknown environment they are facing a lot of issues. And then after that, in unmanned vehicles, it can be expandable or recoverable, and can carry a variety of payloads depending on their type. Number one is type, second one is functionality, third one is operational characteristics, and then what are the specific objectives we want. All those areas we can use it. And why we have started this course, Unmanned Aerial Vehicle, I will tell you, particularly me. Because when I attended the aviation 2019 in New Delhi, so they said that the 2030 or 2035, the drone area will be booming like anything. Okay, so for delivering food products or delivering the couriers or delivering any kind of goods, the drone area will be booming like anything. So that is the reason, main reasons we have started this value-added program of unmanned aerial vehicles. Okay. Second one is type of unmanned vehicles. It is not related to aerial, but generally you have to know that what kind of unmanned vehicles are there. One is unmanned aerial vehicles, which we are studying now, and then unmanned ground vehicles are there, and unmanned surface vehicles are there, and unmanned underwater vehicles are there. The first one we know, and that is only we are going to see for next few weeks. And then unmanned ground vehicles, this is mainly for military purpose, agricultural purpose, goods delivery, you know, Amazon, so pick and place or to deliver it. All those things we are using this unmanned ground vehicles. Unmanned surface vehicles, it's like on the surface of the water when the vehicle is moving. Okay, those things. Anyway, we are going to see one by one. And then the unmanned underwater vehicles are used to, actually mainly they are used to surveillance purpose, and then pipe inspection kind of a thing in the underwater, and then any assembly which we have to do it in underwater. So all those things are done in UUVs, okay, unmanned underwater vehicles. And one more thing is about all these
sir,
things. Yeah. Tell
sir,
me,
I have one query. Sir, I have one query that like in unmanned aerial vehicle, basically we are not using this in unmanned aerial vehicle and that unmanned underwater vehicle. Both are two different things. And in underwater vehicle, most of you are using that master slave concept.
Exactly.
And
in aerial vehicle also we can use master slave concept.
In unmanned in aerial vehicle also, but just like basically that master slave concept more required in unmanned underwater vehicle as compared to aerial vehicle, because it's somewhat difficult that to track the object like which in underwater.
Yeah. Actually, yeah, I'm having a video. We will play that and then we will understand. This particular, that is what you said is correct. This particular slide is to give an overall view about unmanned vehicles.
Yes, sir. So this is 4 kind of vehicles are there, no? Aerial, ground, surface, underwater.
Yes, yeah, please.
Okay, so my query is that like this master slave concept is applicable to all the unmanned aerial vehicle, or only that it's applicable to like that underwater or aerial, because this is 2 most important things. Okay, but ground and surface, for this also we want master slave concept.
Yeah, very good. All these vehicles can have a master slave configuration. So I will give an example, for example. Okay.
Yes, sir. Yes, sir.
We are having agricultural land, for example.
Yes, sir. Yes, sir.
Okay. At that time, I should have a drone, and also I should have a ground vehicle. Okay. So the drone will give the ground vehicle will give an information that to the drone that is these are the areas you have to spray pesticides. Okay. So that drone can be combined with the other drones, that is master drone, will give an information to the slave. Okay, and they can go to the, yeah, exactly. They can
yes.
and they can create a specific.
That means it's applicable to all the means unmanned aerial vehicles. It's not only for the ground and air.
No, ground. Why we need means because the signals we will lose easily in unmanned underwater vehicles. You know that in space you have open spaces there, so signal loss is minimum compared to the underwater because of its pressure and then density, all those things. That's only instead of one vehicle, we are having master slave configuration in underwater vehicles. If suppose one vehicle we have lost in communication,
signal, then it will have.
Yeah, other two will give the details. That is the reason. Yeah. Okay.
Basically, it's used for like defense section, no?
Exactly.
Defense.
That is, yes. Okay.
Fighting.
Okay, fine. Thank you. So this one, and then so this is the thing what I want to convey to you in unmanned vehicles. So we are having space, and then we are having unmanned aerial vehicles, and then unmanned surface vehicle and underwater vehicles. Okay. So space we are concentrating on micro and nano satellites, and then UAVs. You know that different varieties are there. So this particular value-added program, we are going to focus more on air, okay, but little bit we have to know that what are the things are there, okay, and this one ground vehicles also there, and that surface vehicle also there, and underwater vehicles also there. Okay, these are the things. Okay, general. So when you come across what is unmanned vehicles means, you have to know all these things. Okay, fine that. So coming to the first one, unmanned surface vehicles, just you can watch the video. Hope it will play. Is the video is visible?
Yes, sir.
Yes, sir, but the audio is not.
But the audio is not coming, so.
Okay. Oh, sorry. I will enable it.
Yes,
okay.
sir. The audio is not coming.
Okay. I'll check it. Okay. I'll check it out. At present, it's okay.
Now it's working, so.
Okay. Thank you.
Coastlines and marine facilities are vulnerable to threats and illegal activities. Israel Aerospace Industries, a leader in development and production of systems for the defense and commercial markets, present the Katana, a revolution in maritime operation. The system comprises the following elements.
So can you please increase the volume if possible?
Wide range of payloads, command and control.
It's maximum.
And
okay, sir.
Communication systems.
It is in maximum mode.
The vessel is an exceptional platform that supports all operational needs. A range of advanced payloads produced by IAI is a key factor for effective mission execution, including the radar and AIS, a variety of electro-optical payloads, obscuring system for 360-degree obscurant protection. A variety of weapon systems can be integrated according to customer requirements. Stations support advanced C4I capabilities. C4I system can be operated from land or from a mothership. Allows to use all these advanced features also in manned operational mode. The Katana, dual-use unmanned surface vessel, a real revolution in maritime operation. Which crosses the borders.
Okay, it's a kind of unmanned surface vehicles, and Maybe I will increase the volume later. Actually, it's the maximum volume in that. Okay. So what we have seen is it's a kind of an unmanned vehicle, okay, which will go only on the surfaces. Okay. So the advantages you have seen that for what are the purpose of that, alarming the people, those who are nearby, and then for the safety purpose. Okay. So all those things we are using this kind of unmanned surface vehicles. Okay. And one more thing, if suppose you are interested in this kind of thing, you can concentrate more on what kind of area we are going to implement on this kind of unmanned surface vehicles, whether it is for a small area of pond or lake, or it is for a sea. Okay, so according to that, we have to design our own system. Just an information. Okay, that's the thing. And you know that after watching the video, these points will be easily, you can remember it. That is boats or ships that operate on the surface of the water without a crew. Okay, whether the system is autonomous or semi-autonomous, can anyone say?
Semi, sir.
Semi-autonomous.
Yeah, very good. Semi-autonomous. Okay, can we call this one under tele-robotics? Do you know what is tele-robotics? Yeah, tele-robots are actually, we have to control with the certain range of controller will be in one place, and then the vehicle will be in another place. So we can call that as tele-robotics. Okay, so these are the areas. Thank you. So it's actually a semi-autonomous. Otherwise, we can call this kind of operation as a tele-operation. Okay, where the controller will be in one place, and then the vehicle will be in another place. Within the range, okay, there will be certain range where he will communicate to the device and it will perform the operation. Okay, that is called teleoperation. And as here, unmanned surface vehicles are valuable in oceanography, we have seen, and powered seaborne targets and mine hunting, we have seen how it is targeting the the ships and other things. Okay, and one more thing is this one only I want you to concentrate. Okay, seaweed farming. Okay, this is used actually. So farming, we are doing it in sea also. For that, these kind of unmanned surface vehicles are used. So please concentrate on this particular area if suppose you are interested to do some research in this kind of unmanned vehicles. Okay, seaweed farming, it's a broad area, but it is not focused more on research, or it is not taught in the classes. Okay, and then sail drone is used primarily in oceans for data. This is general. Past 100 years we are doing that, the data collection and other things. The important thing from this slide you have to understand is, one is seaweed, another one is the teleoperation. Okay, that is the thing. Okay, fine. So coming to the unmanned underwater vehicles. Okay, I can play a small video, and then I can ask few queries. Then we can have a break for 10 minutes. Okay.
Deep sea operations can be more challenging than space exploration. When astronauts sent messages from the moon, there was a 1.2-second delay before they were heard on Earth. Yet when aquanauts sent signals from the Challenger Deep, they took 7 seconds to be received. Only the most advanced technologies can help us explore this complex frontier. Underwater inspection and monitoring are essential for many industries. Operators deploy professional divers and ROVs, but their effectiveness is limited, especially at great depths or in rough seas. As maritime operations expand into deeper waters, more remote locations, or more complex conditions, operators need more intelligent, safer, more cost-effective solutions. Autonomous underwater vehicles, or AUVs, are wireless robots that can safely perform complex tasks, potentially at lower costs than divers and ROVs. At TNO, we apply key technologies that enable AUVs to be deployed for autonomous maritime inspection and monitoring. Let's explore how this works. The TNO Vision uses acoustic signals for underwater communication. We develop high data rate solutions for wireless streaming of rapid, high-resolution sonar images and compressed videos. We also created underwater modems and designed mission planning software to determine where to best deploy the modems to create a communication infrastructure. Next, we enable multiple AUVs to cooperate with each other
Ready to begin our mission, we use 3 AUVs to inspect a selected area of the seafloor. If one vehicle fails, another vehicle can take over its tasks, and as autonomy improves, even less operator interaction will be needed. With TNO, you can use the latest technology and AUVs to make your underwater operations safer, faster, and more cost-effective. Are you ready to deploy wireless solutions for your maritime operations? Get in touch with TNO Maritime and Offshore. We're ready to explore with you.
So this is related to unmanned underwater vehicles actually. So the vehicles operate underwater without a human occupant. Okay, and you know what is the advantage of autonomous underwater vehicle compared to ROVs we have seen. Okay, remotely operated underwater vehicles and autonomous underwater vehicles. Okay, can anyone say some suggestions on that? Why we have to, suppose if you want to design this, any one purpose, can you say that? Yes, sir, I want an underwater vehicle, whether it is wired or wireless. For any one of the applications, can you suggest?
Sir, as we know, the tensions between China and India.
Yeah.
China has a number of submarines.
Yes.
But India, in India, we have very less number of submarines. Exactly. And it is going to take more time to build more number of submarines.
Exactly.
So what we can do is we can make such type of drones, and we can use them for the defenses. If China launches an attack with their submarine, we can use these drones against them.
Exactly. So these kind of underwater vehicles we can use
to search for wreckage.
Yes, sir. Please.
To search for wreckage.
Exactly. That is also there. So that is generally very good points actually you have given. Any specific point which is related to humanity?
Also something like deep underwater exploration.
Yeah, underwater exploration is a very good one. Okay, what kind of gas is present there? What kind of material presence there? Okay, and whether whether it will create some issues to the human if they are reaching it, or what kind of species are there. Those things are we are doing it. Apart from that, any specific in and around some cases you would have
search for
sir, water pollution monitoring
and stuff.
Very good. Water pollution is one. Very good.
Sir, the weaponry left by previous wars that can be hazardous.
Yeah, weapons. Very good. Then,
sir, underwater to find something that has been lost, sir.
Yeah. Okay, that's also okay. What about plastics? Okay, which one is polluting our ocean more?
Plastic.
Plastic.
Okay. So we have developed a small system to identify all those things, and then we got top 20 in that competition also. That is Texas Instruments organized and the India Innovation Challenge Design Contest. So please, if you are interested, please note down this. This contest, okay, for the students and also for the professors, they can guide also. Texas Instruments used to conduct yearly once. Okay, these kind of design challenges where these kind of unmanned underwater vehicles are playing a vital role. Okay, so I think we have participated in 2018, and then we reached up to top 20. Okay, India Innovation Challenge Design Contest. So what we have done is we have made a small underwater robot which will collect the plastics and then crush it and then put it inside, and then once it is coming back, it will throw it up wherever it is necessary. Okay, that's the thing. And one more thing is why we have started working on underwater vehicles. I will tell you. After that, we can go for a break. Okay, and nearby my area, so I have heard that some of the childrens, they went to take a bath in a small pond. Okay, and then unfortunately, one of the person, he get inside the pond. Okay, he actually we missed him around 3 p.m. actually. Okay, and we got his body only on next day morning when it was floating. Okay, so now you will understand what is the need of real underwater vehicles for our environment. Okay, actually he lost in 3 p.m. but we got his body on very next day morning when it was floating. Because even 10% we went inside the pond, but we couldn't find his body. Okay, that much it is polluted nearby. Even in the pond is somewhat clear, but you know that we don't know the depth, what kind of materials will be there, nothing will be there. Okay, based on that, what we have come across is, we have started working on that. Okay, we have started working on that, and then we started making a small low-cost system. Just I will show you the video. This is based on our interest, you know. It's not based on whatever we are achieving it. Based on our interest, what we have done is, at least for swimming pool area, whether the quality is good or not, our known environment. So we have developed our own underwater system. Yep. Okay, it's a simple system, which will just, it will go and then it will come back. It's wired actually. We have made it in wireless also. Okay, so these kind of system also we can make, and then we can give it to that area where we can go and sense some of the bodies which are present in the unknown environment. Okay.